Hey guys, in today's video we are going to solve LeetCode question number 1582, that is special positions in a binary matrix. So this question is being asked by Google in last 2 years and Bloomberg as well. So let's see what this question is all about. So in this question we are given a binary matrix m cross n matrix and we have to return the number of special positions in matrix. So firstly we need to understand what the special position is. So we can say a position I and j is special if the value of that position is 1, and not only this but the elements in that row and column are 0 except this position. So if I'm saying I is 0 and j is 0 and at this coordinate the value is 1, then I want to make sure that the rest of the 0 row and rest of the 0 column is not having any 1 value. Then only I can say that this coordinate or this position is special. So as we can see in this example, this 1 where row is 1 and column is 2, we can see that the position value is 1. And if I'm going to check this whole column number 2, I can see rest of the columns are having rest of the positions are having 0 value, and the row as well, the row number 1 is having rest of the values as 0. So how we can solve this question? The first approach with which we are going to solve this question is a brute force approach, in which we'll be traversing each and every position in this matrix. So if I'll start from here, so firstly I will be at this place, then this place, then this place, and so on. I will be traveling through this whole matrix, and once I'll reach a position, suppose I'm at this position right now, so I will check firstly if it's 1, then I will check the possibility of this position to become a special position, right? To be a special position. So for that, what I'll be doing, I'll be checking this whole row and I'll be checking this whole column. And as I can see, row is satisfying the specified condition, but the column is not satisfying the required condition, as this is having 1 as the last element in this column. So I know that this position is not the special one. Then what I will be doing, I will be going to next position, and at this position I can see it's 0, so I don't have to check for this. Then I will be going to this position, again this is 0. Then I will go to next row. In this row again I will do the same thing, 0, so no need to check, 0, no need to check. And then I will reach this place where I will see it's 1. So what I will check the possibility of special position. So for that, firstly I will check the rows, the whole row, rest of the row, it is not having any 1. Then I will check rest of the columns. So this column is also not having 1 and this column is also not having 1. So this position in the column is not having 1. So in this case, I know that this position is the special position. So my answer will be incremented by 1. Then I will again go to next row. I will come up to this place. This is 1. So I will check the possibility of special position. But as I can see in this column, there is one more 1 present. So this is not going to satisfy the required condition. So this will be the first brute force approach, where we'll be traversing this whole matrix and checking for each and every position. So what will be the time complexity of this approach? If I have to traverse this whole matrix, then I'll be using 2 for loop. For that, it will take like big O of m cross n, right? This will be the time complexity for traversing this whole matrix. Now I am not only traversing this whole matrix, but I'm also checking the possibility of special position if it's 1. So in that case, what I will be doing, I will be again traversing through this row and column. So what will happen? This m cross n, inside of this m cross n, I'm also doing m plus n, where m is the length of row and n is the length of column, right? So the time complexity will be big O of m cross n into m plus n, where m cross n will be for traversing the matrix and m plus n is for checking the row and the column for special position. So this was the first approach and this was the brute force approach. So let's quickly code this solution. So just to save our time, I am directly showing you the whole code and let's go through it. So for this approach, I'll be showing you only the Python code. The next approach that I'll be showing you will be a bit more optimized one, and for that I'll be coding not only Python but Ruby code as well. So here what I did, firstly I created the answer variable, then I'm calculating m and n, which is the length of row and column. Then this is the for loop inside which I'm saying if it's 0 then we don't have to do anything if that position is consisting of 0 value. But if it's not, then firstly define a flag which will be good equals to true, or you can name it anything. For now I am naming it as good. Then I am using a for loop for rows, right? Because firstly I need to check if any row is having value equivalent to 1. So if any other position in that row is having a value equivalent to 1, that what I'm doing, I'm changing the value of my flag and I'm breaking the loop, and then again I'm doing the same thing for column. So if the column is also having any position with 1, then I know that it is not going to satisfy the required condition and I will change the value of my flag, break the loop and step out and check if the good flag that I created is being changed to false. In that case, is not being changed to false. In that case, I am incrementing the answer, else I am not incrementing the answer. So this was the brute force approach. Now let's see how we can optimize this approach. So for that, let me just first clean this board. So now our board is all neat and clean for second approach. So what can be a more optimized approach than the one that we just saw? So there are few things that we need to understand. That first one is we need to check for special positions, right? And special positions are something that we can consider only if the row and the column both are having only one position with value as 1. This is something that we need to check. So the thing is that for checking that the position is satisfying the special positions requirement, I don't have to look through this whole row and column each and every time, because at the end I just want to know that is there any more ones present in this row or column, right? I am only checking for ones so that I can assume that this is a special position or not. So for that what I can do is I can pre-calculate the sum of ones in all the rows and columns, so that whenever I encounter any position with value as 1, rather than checking for rest of the row and rest of the column positions, what I can do is I can simply go through the pre-calculated data and check if this position can be considered as special or not. So let me show you what I exactly mean by this thing. So what I'm saying is, let's pre-calculate the one count in rows and columns. So if I'm saying for row 1 or row 0, this is the 0 row, right? 0, 1, 2. And similarly, this is 0, this is 1, this is 2 column. So for row 0, what is the ones count? Ones count is 1. For row 1, ones count is again 1. And for row 2, ones count is again 1. Then for column, I'll be checking the same thing. For column 0, ones count is 2. For column 1, the ones count is 0. For column 2, the one count is 1. So this is how I pre-calculated the ones count in all the rows and all the columns. Now what I will do, I will again do the traversing. I will again traverse this whole matrix and I will check if the position is having value equivalent to 1. Then what I will do simply, I will simply check for this rows index and column index in pre-calculated data. So this is the position where I is 0 and j is 0. So what I will do is, if this value is 1, in that case, check the row pre-calculated count at 0 index and also the column. So if the value is not equivalent to 1, that means there are more than one position in this row which is having value equivalent to 1. In that case, I won't be considering this position as special. But if the value is 1 for both row and column for the indexes or the positions at which I am currently present, in that case, I will simply increment my answer. So for this position, I won't be incrementing it because the column is having value equivalent to 2, which is greater than 1. So I will again go to next position, this, and as we already know, these positions are not going to satisfy. So let's just jump to this position where our row R index will be 1 and our column index will be 2, right? So what I'm saying is, now check the one index in row, that is this one, and column index at 2, so this one. I can see that this one and this one both are having value equivalent to 1, so that's why I can say that this position is special position. I can increment my answer and then at the end I will be returning it once my traversal is ended. So what we have done is, firstly we created two pre-calculated arrays where we are storing the ones count for rows and columns separately. Then again we did the same thing that we had done in the previous approach where we were traversing through this whole matrix checking if the position is having 1. In that case only we are checking our pre-calculated data and then coming to a conclusion whether this position is having a special, whether this position is a special position or not. So what is the time complexity of this approach? So firstly, as I am traversing this whole array, so time complexity for that will be m cross n. And separately, I have previously calculated this row ones count for rows and columns. So for that, it will be big O of n and big O of n. So this will be the whole time complexity. So as this is the dominant one, so we can consider that big O of m plus n is the m cross n is the only time complexity. Rest we can ignore. And space complexity is big O of m plus n, as m is for rows array where we are calculating the ones count, storing the ones count, and n is for the columns array where we are storing the columns ones count, right? So time space complexity is going to be big O of m plus n and time complexity is going to be m cross n. So this was the second approach in which we use the pre-computed data in order to cut off our time complexity. So this was way more efficient than the previous one. And now let's jump to the coding part where we'll be coding in two programming languages, that is Python and Ruby. So firstly, let's code the Python solution. Let me just remove this previous approach code. And for this approach, what we were doing is, firstly, we will be calculating the row and column length. So this will be length of matrix and length of matrix at 0 index. After this, we want to create two arrays. Firstly, for row count, then col count, which will be 0, like I'm initializing it with 0, and it will be of row size, and this will be of column size. And after this, what we were doing, we were traversing our matrix. So inside this, we were checking if matrix at this position is having value equivalent to 1. So firstly, we need to pre-calculate our ones count in rows and columns, right? So for that, what we will be doing, we will be checking if it's 1. If the value at this position is equivalent to 1, in that case, simply do row count at this index by 1 and column count at this index by incremented by 1. After this, our pre-calculated row count and column count array will be populated. So after this, what we will do, we will again create a for loop for traversal, but before that we need a variable for storing our result. So let result be 0 for now. Then again for r in range row and for c in range column or call. Inside this, again we will check the same thing if matrix at this position is equivalent to 1 and row count at this index is also equivalent to 1 and column count at this index is also equivalent to 1. In that case, increment our result by 1, and after stepping out of this loop, simply return result. Now let's check if it's work. I did something. Okay, this is the typo. It's not comma, it's asterisk. Okay, let's submit it. So you can see on left side it is accepted. Now let's code the Ruby solution. So in Ruby, firstly we did the same thing, that is initializing our row and column with length, and then row count will be array.new row and initialize with 0 values, and column will be of length call and initialize it with 0 value. After this, what we have to do is we are saying from 0 to row dot each to r. So this will loop over these values, and we can do the same thing for column as well. Call dot each do c, and then again this. Inside this, what we were doing, if matrix at this position is equivalent to 1, in that case simply update the row count at that index, right, and column count as well. So this will populate both the arrays, and after stepping out of this loop, again we have to initialize our result, which is initially 0, and then we will again create a loop, this loop from 0 to row dot each do r, and then end statement. Then inside this we want one more loop which will do for column, and it will be using c. Inside this we are saying if matrix at this position is equivalent to 1 and row count at this position is also equivalent to 1 and column count at this position is also equivalent to 1. In that case, simply increment our result. So this is how we can write our if condition. and at the end I'm saying return the result. Now let's run and check if I hadn't made any mistake. I think it's worked fine. It is going to work fine. Okay, so it has been accepted, you can see. So this was the whole solution, and I hope that you find this video helpful. And if you really find this video helpful, then you can like this video, subscribe my channel, and I will soon come up with more such questions. Till then, take care, keep messing with algorithms, and thanks for watching.